Once we have the area formula for a parallelogram, it opens up many opportunities for other area formulas, starting with the triangle. And here's what I mean by that. If I've got some triangle and I want to get its area, if I were to make a photocopy of that triangle and flip it upside down, it would come up and connect with the triangle so that the two pieces together, it would make a parallelogram. Which means it has almost the same area formula. The area for a parallelogram is equal to base times height. But that's actually two triangles. We only want one triangle, so we're going to take half of the base times the height. So for example, if I've got this triangle here, where the base is 6, this right diagonal is 3, the left diagonal is 5, this vertical distance here, that makes a right angle, I'm going to call that 4.3. When I recognize that's a triangle, we can say the area is 1/2 times the base times the height. Remember, the base and height have to meet at a right angle, which means the 5 and the 3 don't meet anything at a right angle. I don't really care about them. The base is 6. The height is 4.3. That meets it at a right angle. And when I multiply those together on my calculator, I get 12.9 square units in that triangle. A similar thing happens with a trapezoid. A trapezoid is a shape that's got two sides that are not parallel and two sides that are parallel to each other. If we do much the same thing we did before, where we copied that trapezoid, flipped it over, and slid it, so I put the long side here at the top and the short side here at the bottom, what I end up with is this larger shape that, again, is a parallelogram. Which means the area formula is going to be very similar to the parallelogram formula, base times height. And then we'll have to do 1/2 because there's two of them. The catch is there's actually two bases on this parallelogram, the base on the top and the base on the bottom, that when they got flipped, the total base then of this parallelogram is going to be the sum of the top and the bottom, the A plus the B. We'll call those the two bases, the short base and the long base. And then that gets multiplied by the height. So for example, if I've got this unusually shaped trapezoid here, let's say these bottom sides meet at a right angle. Let's say the left is 9, the right is 2, the bottom is 4, and the diagonal is 5. It's still a trapezoid. The catch is I need to remember that the height meets the bases at right angles. The bases are parallel. In a trapezoid, the bases are parallel, and the height meets the bases at right angles. So it doesn't matter which way I twist this shape. The A is 9 and the B is 2. Those are your two bases. In geometry, base does not mean bottom. Base are the two parallel sides. And then the height is the side that meets both bases at a right angle. It might go through the shape, like over here on the left, or it might just connect them at right angles on the edge, as long as they're right angles. So if I do my area formula is 1/2 times the height of 4 times the bases, which are 9 and 2, added together. When I put that in my calculator, I end up with an area of 22 square units. So knowing the parallelogram formula helps us find an area for triangles and trapezoids as well. And our next video is going to take a look at another area formula where you might not expect a parallelogram to show up.